Welcome to Ask and Learn.
So in this problem, we have marbles that travel through a tube and then exit that same tube. So we want to find the distance those marbles travel in the x direction so we know where to place a can to catch them, and we want to find the velocity as they enter that can. So we're given the mass of these marbles, which is 5 grams. So you divide by 1,000 to get kilograms, so you get 0.005 kilograms. So again, we want to find the horizontal distance, and here it's r, and the velocity we'll call velocity c as it hits the can. So to find r, or the horizontal distance, we know that we can call it x, and we know that x is equal to the velocity times time. So we need to find the velocity and the time. So to do that, we use the work energy theorem, because we have work being done by the weight of the marbles, and it has its own kinetic energy as well. So we have the initial kinetic energy plus the work being done, and here the work is done from A to B. So from the beginning of the tube to the end of the tube is equal to the final kinetic energy. And we know that initially it has no velocity, so the initial kinetic energy is 0. So now we're just left with the work being done. And here, the only work being done is by the weight of the marble. We know that the weight is just mass times gravity, and work is force times distance. So it's this force, the weight, times the distance, and the distance between the beginning and end of the tube is 3, the top of the tube, minus 2, the bottom of the tube. This is equal to the final kinetic energy, which is 1/2 mass of the marble times V, we'll call it VB squared. So this is the velocity that the marbles exit the tube with, and this is what we want to solve for. So plug in your numbers. We got, so for the left side we have 0.005 times gravity 9.8 times 3 minus 2, which is just 1, and equal to 1/2 times mass, which is 0.005 times VB squared. So let's solve for VB. So VB is equal to, so the left side we put it into the calculator, and then 1/2 times 0.005, we put that into the calculator, and then divide this by the left side. So we have VB is equal to 0.049 divided by 0.0025, and then to get rid of the square in VB, take the square root. So VB, the velocity of the marbles as they exit the tube, is 4.4 meters per second. Okay. Now that we have velocity, we can find time. We can use that. We can find it using a kinematic equation, which is y final is equal to y initial plus the velocity initial in the y direction times t plus 1/2 a, in this case a is gravity, times t squared. So we know that initially we can say it's at 0. The velocity initial is again 0. So y final, so this is the distance after exiting the tube. So we have 2 is equal to 1/2 g 9.8 times t squared. So we just solve for t. So we have t is equal to 2 divided by the 1/2 times 9.8, which is 4.9, and take the square root to get rid of the square. So we got t is equal to 0.63 seconds. Now that we have the velocity exiting the tube and the time, now we can find the horizontal distance x is equal to 4.4. The velocity times 0.63, the time. So x, or in here, they call it r, is equal to 2.83 meters. So now, to find the velocity as it hits the can, we can call that velocity c. We can use again the work energy principle from A, the very beginning, at the top of the tube, all the way to the end as the marble hits the can. So still the initial kinetic energy is 0, and the work is still is a little similar. So we have again the work, which is the weight, mass times gravity, times the distance, and here it's 3 because this is the very top of the tube, is equal to 1/2 the final kinetic energy, 1/2 times m, the mass, 0.005, times the velocity as it hits the can, vc squared. So again, plugging this into the calculator, dividing both sides by this side, we have vc is equal to 58.8, and then square root to get rid of the square. So vc, the velocity as it hits the can, is 7.67 meters per second.